Everyone, my name is Salami Sodiq Adirutimin, a chemistry teacher of Global Kills Academy. I'm here to introduce to you chemical kinetics, a topic in chemistry. As we all know, that when we talk about kinetics, we are talking about rates, timing, that is how fast a reaction is or how slow a reaction can be. So it all depends on the mechanisms of the reaction. And let us look at three parts into chemical kinetics. The first one is that some reactions are very fast. We call them fast reactions. So they occur instantaneously. Look at silver ion with chloride ion to give white precipitate of silver chloride. This reaction is a fast reaction and it is difficult to monitor under the same process. The second one is, look at the decomposition of hydrogen peroxide in the presence of manganese 4 oxide to produce 2 molecules of water and oxygen gas. This reaction is a slow reaction. So because it's slow, it is very easy to be monitored under the same process. Another one is thermal decomposition of marble chips, that is calcium triisocarbonate 5. Thermal, by heating, it decomposes to calcium oxide and CO2 gas. Now, rates of chemical reaction. What is rate of chemical reaction? The rate of chemical reaction can be defined as the time taken for reactants to be used up. It can also be defined based on concentration. Then we define it as the change of concentration per unit time. And mathematically, you see that the rate of chemical reaction is defined by change in concentration all over time taken. Graphically, this is the graphical representation of the graph of concentration against time. Now, looking at this is the product and this is the reactant. Now, if we look at the concentration of the reactant decreases steadily until all the reactants are used up. And also, look at the product. The concentration of the product increases steadily till it becomes constant. Now, this takes us to collision theory. Collision theory states that the reactant particles must collide together before any reaction can take place. For example, if we have a reactant A colliding with another reactant B to produce a product C and D, as the case may be. Now, we have 2 types of collision. The first one is effective collision, and the second is ineffective collision. Now, what is effective collision? Effective collision is a collision that results to the formation of product. That is, any collisions that result to formation of product, it means that that collision is effective. And of course, you know, collision can also be ineffective. How? When the collision of A and B did not result to formation of D, C, and D, then it means that that collision is ineffective. Now, there are 3 factors that is responsible for collision theory. That is, collision theory, either effective or ineffective collision, depends on three factors. And the first one is the frequency of collision. The second one, the energy of the reactant. And the third one, correct orientation. Now, the frequency of collisions. From the kinetic theory of gases, the third postulate. Collisions of a gas, molecules collide with each other and to the wall of the container. So when I'm talking about frequency of collision, I'm talking about how often collision takes place, or how fast collision takes place within the molecules of the gas, either cohesively or adhesively. Now, and also, the fifth postulate of kinetic theory states that the absolute temperature is directly proportional to the average kinetic energy. This implies that when the temperature increases, the kinetic energy increases. So when the kinetic energy increases, the molecular collision increases. And when the molecular collision increases, the frequency of collision tends to increase. Thus, leads to increase in the rate of reaction. So, for an effective collision, any collision that have high frequency, that collision will be effective. So, when the frequency is low, the collision will be ineffective. That is, it will not form a product. Then the second one is the energy of the reactant. What do I mean by energy of reactant? Look at the equation above. A plus B, these are reactants. And proceed to give us C, product, and D. Now, any reactant colliding, they are colliding with a definite energy. And that is why in physics, we learn elastic and inelastic collision. Now let's take, for example, the energy required for A is 5 kilojoule, and the energy required for reactant B is 10 kilojoule. Now, you need to understand that every reaction has activation energy. And from our lesson taught last year on energy and energetic effect, we explained activation energy, which is the minimum energy required for a reaction to take place. So every reaction proceeds with activation energy. Now, what will make a collision to be effective is only when the energy of reactant is greater than activation energy. So, the activation energy, for example, look at A and B with energy 5 kilojoule and 10 kilojoule. Now, to produce a product C and D, now between A and B, to the formation of product, there is a barrier posed by activation energy. And for the energy of reactant to overcome the barrier, then it means that the energy must be greater than the activation energy available for that reaction. So if the activation energy is 5 and the energy of reactant, total energy of reactant is 15, So it implies that the energy of the reactant particles will overcome the barrier posed by activation energy. So the reaction can proceed and a product can only be formed only when the energy of reactant is greater than activation energy. And if the activation energy is greater than the energy of reactant, then the collision will be ineffective. So the third one, correct orientation. It tells us the reaction phase. And reaction phase can be solid phase or state, liquid phase or state, and gaseous state or phase. So a reaction that's supposed to proceed, proceed at liquid state, if made to proceed at solid state, it cannot produce result. Look at H2 gas plus Cl2 gas, and to give you hydrochloric acid gas. This reaction, obviously we can see that these reactions are in gaseous state. Gaseous state, hydrogen gas, chloride, chlorine gas, HCl gas. So if this reaction is made to proceed at solid state or liquid state, it cannot produce result. So therefore, correct orientation is very important. For example, look at Haber process. Production of ammonia, N2 gas plus 3H2 gas to produce 2 molecules of ammonia gas. This reaction occurs at gaseous state and not just at high pressure. So it therefore tells us that there are 3 factors in which collision theory depends on. Number 1, as I said, the frequency of collision. When the frequency is high, then the collision is effective. When the frequency is low, the collision is ineffective. Then the second one, energy of reactant. When the energy of reactant exceeds activation energy, then the collision is effective. But if the activation energy is greater than the energy of reactant, the collision will be ineffective. And the last one, correct orientation. A gaseous phase reaction must not be allowed to proceed at liquid or solid state. So it is under this factor that you cannot classify a reaction and a collision as effective or ineffective. We have come to the end of today's lesson. We continue next week.